I'm so tired.
Did you study for it yesterday?
Yeah.
I reworked some of the problems on our old tests that I got wrong.
I take notes and rework some more quotes. Sammy, I have a question for you. So I couldn't get the Common App to open.
Did I send it to the right email?
Some of the lights off. Yes,
It's spooky.
it's final Okay, let me show you what happens. Here's my notes.
Those are blue.
Okay. So every time I click on this link that you sent me, so this is like the Common App thing, and every time I click on this link, I don't know what to do. This is like the second day of this.
I'm gonna go to the Common App website and see if it.
What is the Common App website?
I think it's just commonapp.org. And I'll see if they have like an activate tab.
See, I can't even, that's not even a website on my.
Commonapp.org?
Yeah, it does not open.
If you Google Common App, does it come up?
See, this is what comes up. This virus? See if you can get to it on your computer. Are you able to open it?
I'm able to go to the Common App. I'm trying to find how to.
I can't even get to the Common App. Let me try and Firefox. I feel like I did try it there and it's not the same thing. Yeah. It says the page is under construction. Well, I finished your recommendation and I sent the one to MIT, but I can't get on this Common App one.
I'm trying to figure that out. Because I don't see a place on their website where it just lets you start. Like, I see a recommender.
I can't even get to the Common App website.
Does the Davidson Computers let you go to it? Or.
I don't know. Is it really just commonapp.org? COMMON?
Mm-hmm.
I mean, seriously, it keeps saying pages under construction. Coming soon. It says that on Google Chrome and Firefox.
I always use Google Chrome for it. I don't either. It's letting me on their website on my computer.
I don't know what to do. Maybe I'll call the IT guy today. See if I have a virus or something.
I just tried on my phone and it doesn't work. On your phone?
Mm-hmm.
Why is it working on my computer then? What's wrong with my computer?
Maybe you have the right virus.
Honestly, I wouldn't be surprised. Every computer I've gotten And I got a notification on my old one that said hackers could see my webcam. And so I taped it over. I was like, no, that's not happening. I don't know.
I don't know what to do.
I've never had this issue.
It's a really good letter, though.
Thank you, Splinger. Brittany. Have you
I
studied
had Miss
for
Johnson look over it for me.
No. No. Well, I reworked some problems on the old test. So there's good news and bad news about it being right or wrong. If worst comes to worst,
partial credit.
yeah, you can't get partial credit.
The
But
worst
if
you can
you
do is a
guess,
0.
if you guess, you can get it completely right if you get it right.
That's a
Don't.
pretty big guess, Sammy.
Yeah.
Well, like if you
I
narrow it
can
down.
guess and get partial credit.
Well, like let's say you have 30
But now
seconds
you
left
can't.
before the final exam is over. You've narrowed it down to 2. You can guess and get it completely right. But if it wasn't multiple choice, you'd be there like, okay, time to put down a random number.
Yeah, I've given up on the B.
Let me see if I can get to the common
It's
app
just
on
not
the
gonna
computer.
happen.
I gave up on it.
What's going on here?
I will sleep in these terraces. I'm not sleeping.
One out right there, but I think it's.
And they got the front ones kind of a fire.
Springer was having trouble logging in, and I'm trying to see because it's letting me in on my computer. But it's not letting Chloe in.
I think you got 1 to 2
Yeah, it
out.
does the same on this computer. Page under construction. Coming soon.
Weird.
Oh, wow.
This is what I'm going to. I'll show you.
Yeah, you get the mother load.
Those are like,
That's right, right?
Yeah.
And then it goes to that.
Really?
That's weird.
What in the world is this?
Me and Reza had to leave a bit early because we have an exam at 9.
Dale?
Hey,
See, when I go to Common App, it takes me to the website. But I don't know why, because I'm on the Davidson Wi-Fi. And
Is Dale not there?
Oh.
Okay. We have high optimization with the race.
yeah, I don't know what that is. My priorities here.
Oh my
And then
Wait,
it's increased.
Is that their chances for winning?
Yeah.
Like the Super Bowl?
Miss Corner.
No, the game on
Friday.
Wait a second.
Super Bowl's not until February, right?
February 4th.
Sammy has this
not,
down pat.
Not that I have it in my calendar or anything.
Super Bowl date. I have to keep this free.
Did the Patriots lose against Dolphins last night? I was gonna watch it, but then I was like, no, I should probably stay. Ooh.
I love how excited you are about this and not anything else.
There's no other reason our chances would win.
Do you have your exams?
This is the chem exam.
Tape to us?
Yeah. He let us choose one, and we took the rest of them in class so we could take the final home.
Okay.
Final's actually not that bad. It's just one question that's giving me grief.
Oh, this one? What everyone else was?
Yeah.
No, like one question that she's having trouble on.
Oh.
Yeah.
No, it's just
Don't
one
scare
question.
me.
Hey, Dale.
Yes.
So this week is final exam week at Davidson. And a
Yes?
couple students have an exam that starts at 9 a.m. today, so they might have to leave a little early.
Okay, that's fine. And will they be around tomorrow and Thursday for final
Is
exams?
everybody?
Yeah.
Yeah.
It's just today.
Okay. Well, and this exam is, in my opinion, so short, 15 questions per day, so I don't think I'll have too much trouble being done by 9, I would think. So I'm saying just do a standard 8 to 9 or 8 to 9 to 5 for the exam, so we'll start and finish this.
So it's not going to be the kind of questions that take 15 minutes to work through or anything?
I don't know. I didn't write the exam. But I don't think so. I mean, it's multiple choice. I wouldn't think it's like that.
I can't help you with this. But you sure? Dude, I'm taking intro chem, you're taking gen chem. What is
That's an opal diagram.
never been over
I don't understand them. I just know the arrows go up and down.
Correct.
The amount of-
And I'll start on page 10. You'll have several that are very, very correct.
Close.
But not,
Most correct. That's rough.
yeah, he said those are hard.
Oh, yeah. Most correct is always.
I'm going to drive up there to
See, ours
turn
is
in.
in class.
Here it will be, which one's not correct?
Correct.
I hope you wrote that wrong because that's literally the answer is 13.6.
My daughter, she's a nurse at it's a care unit. And when she got reached state board, they have a question type called multiple, which means multiple choice.
Right.
It's like which of the following sentences it's blah, blah,
Select
blah.
all that are,
And then so you select all that are correct. So if you have like 10 options, if you select even one incorrect, the entire question.
or, get mine right. you get it
And
right.
I'm considering what they do for a living, I'm glad.
Well, yeah, no, I'm.
Yeah, but it's brutal. And the test comes up, and as you start taking the test, it'll cut off either when you failed it or when you passed. So you never know. So you're like, and there's 75 questions to start with. So after you hit 75, you're wondering how many. If you do like 2 or 3 more, you're like, did I fail because I missed so many? They're brutal testing. Have you looked at the iron yard? We're coding.
I want to know what I paid on this third one. So we can
Oh, I
bring
thought
that up.
that was your grade.
Yes. Sometimes they give free developer boot camps, but typically a boot camp
65.
costs $10,000. They're good, but they're expensive. But the iron yard does occasionally free
I'm
ones.
making
He's missing some.
So it's in,
Okay, so
consider
You're making a 92.
what questions do you have for today? Yes, ma'am.
77 on section.
Point 4, number 77. 4. Number 77. Okay, so this one, number 77 on 2.4, we have an equation where y is an implicit function of x, and we're supposed to find dy by dx. So here we'll start 2.4, number 77. Y squared plus 1 over 3y minus 1 equals x. Okay, so we're to find dy by dx. The picture is I do a derivative with respect to x, And if you're dealing with X, then that's straight up. If you're dealing with Y, then it's an implicit differentiation with the chain rule. The next thing to think about is, on this one, there's two ways to proceed at this stage. I have to differentiate both sides, so I could differentiate with a quotient rule on the left side, or I can multiply both sides by 3y minus 1, and then I would do something different over here. So to avoid a quotient rule, I'm going to choose that method. So I'm going to do y squared plus 1 equals, and then if I distribute over here, I'm going to get y minus x. Then I would do the derivative on both sides of this equation. So the derivative with respect to x both sides of the equation. And now it's fairly straight up. So you're going to use right here a sum rule. So what is the derivative of y squared? 2y to the 1 times chain rule dy by dx. And then the derivative of 1 with respect to x is 0. So you don't need to write down, but just for emphasis, I'll write it down. Now, over here, you got to be a little careful. The 3 is a constant, so I can pull it out front. But that's x times y. X times y. So I have to do a product. I do the derivative of the x first, which is a 1 times y. And then I do x times, and the derivative of y is dy by dx. And then the derivative of negative x is just minus 1. You follow all that? This stage is essentially done. In terms of calculus, it is done. But the answer isn't quite done because the answer is to find dy by dx. So now you got to do algebra. So we've done all the calculus. Now it's algebra to get dy by dx on one side, everything else on the other side. So how do we, the rest of it is just algebra. So how do we proceed? Get all the dy by dx terms on one side. So let's see, I'm going to have to distribute a 3 into here, tract it over to this side. So I'm going to have a 2y dy over dx minus a 3x dy by dx equals, and then I have a 3y now minus 1. All that. So I collected all of the quote like terms, all of the terms that have a dy over dx. I collected them on one side of the equation. Now what do? Factor out of dy over dx, and then divide by the coefficient. So if you factor out of 2y minus 3x, then dy over dx divide becomes 3y minus 1 over 2y minus 3x. That's your question? Everyone else follow that? That's good for 2 problems of doing. It's called implicit differentiation. Way back, step 2. Let's see. That's a good question. The question on the table is, okay, good. You worked it out. Now, what would it look like as a multiple choice question? Well, they might give this answer as one of them. But what are some other potential mistakes that could be made? Here they put those markers up here. I don't know if those are. I really don't think those are by race. I'm taking matters in my own hands. Flax. Okay, back to the question at hand. So I started picking one up. So, question at hand. How can I make a mistake somewhere in here? That's a fairly common mistake. Sorry, what? Yeah, I would say one of the biggest common mistakes is not do this as a product. And so, how would you do it if you didn't do that as a product? Like right here, this is the correct thing. So what might you have done if you didn't do that? Maybe just 3 times y? No, just take the derivative of the x and forget the y altogether. So you might have 3. Can't quite see the trash cans always. So you might have another option might be 3y minus 1. Just right there. With no dy over dx. And this would still be, so you might have 2y times dy over dx equals that. So now if you divide by the 2y, you don't get this, but your potential answer might be dy over dx equals 3y minus 1 over 2y. It's like a reasonable wrong answer to me. I mean, it is a wrong answer, but reasonable in the sense that it's a common mistake. What else could you have done that might have been a bad mistake, or just a mistake of video? All bad. Yeah, forget to multiply the x right here. If you did do a product, well, maybe you forgot the dy by dx, or maybe you forgot the dy by dx here. So there's a lot. You see where there's different places that you can make mistakes and come up, work out a ultimate solution that's obviously. Okay? Helps. And folks, this one is not right. We're just looking at potential alternate answers. I'll copy that down as the correct answer. Other questions you want to look at? Find the largest part of the so you're back in the limits chapter. Not the middle.
Cancellation.
Anybody else while Joe's looking, does anybody else have another question they want to talk about?
I have a question.
Chloe?
Can we go to 3.4 and do number 47?
3.447. We'll do that one. We'll do 3.447. $47. So 47, the directions are over on the previous column. So we need to study those for a moment first. So 3.4, number 47 is what we're working on. And the directions say, U.S. Postal Service ships a package under the large package rates if the sum of the length and the girth of the package is greater than 84 inches and less than or equal to 108. If the package is considered the length of its longest side and the girth of the package is around the package perpendicular to its length. So, and it wants to ship packages under that large package rate. So number 47, Linda also needs to mail some architectural plans which must be shipped in a cylindrical container. What is the largest volume that her package can have? What is the largest surface area that a package can have? Volume of right circle, so the hint, volume of right circle in the cylinder with radius R, height H, volume pi r squared H. Total surface area of such a cylinder is pi r H plus 2 pi r squared. Okay? Largest volume. Okay, so we want, we're going to say the length plus girth must be greater than 84 but less than 108. So, okay, less than length plus girth less than or equal to 108. 84 is the most small sign. Okay, that's what it's given to us. Length plus girth has to be in that range. And we want to maximize the volume. Maximize the volume. So that would be, I guess, my constraint. And my objective is to maximize volume, which is equal to pi times r squared times h. So I'm looking at something that is length. And distance around the object is called girth. Girth is the distance around, so that must be 2 times pi times the radius for a circle. And I'm going to say that height here is the length there. The length must be equal to the height that is listed right there in the volume. Okay. So if that's the case, then I have volume equals pi times r squared times length, I guess, if I want it. How am I going to use that with this constraint? L plus G is less than or equal to 108, but G is 2 pi r. So if I use G is equal to 2 pi r right here, there's 2 pi r. I guess I get something like 84 is less than, 84 minus 2 pi r less than L is less than or equal to 108 minus. If I'm going to maximize the volume, I would guess I need a more length and not smaller length. So I'm going to try the big side over here, this big side of my length. I'm going to plug that in for my length here. So then I get volume equals pi times radius squared times 108 minus 2 pi r. I got it down to a equation, 2 variables, V and R. So that's good. I can differentiate that. I'm going to distribute just to make it look easier. So one is 108 pi times r squared minus 2 pi squared r cubed. do this. I'm going to spend a whole bunch of time talking to myself about finding a volume equation. I found a volume equation. Why would I want to do all that?
What do you want to do? What?
All right.
I'm sorry, the audio was a little blurry there. Okay.
Oh, I was saying that I've been talking about making an equation, a volume equation, out of the gateless volume equation, and I converted it to an equation with only one variable, well, two variables, B and R. And then I paused to say, well, why would I have gone through all that? What's my next step?
Well, you're looking for the critical points, right?
Yes.
And then you're going to test it to see. You're going to try the critical points and the endpoints to see which one gives you the maximum volume, right?
Right. So I need a domain for my R. That's the next thing I need. And then I need to find my critical points. So what's my domain of my R values?
Well,
in some sense, it could be as smallest as R is 0, but I'll call that an open-ended 0 because you can't really have a real cylinder with a 0 radius. What's the maximum my radius could be?
is it 108?
I don't know if it'd be 108, but you're on the right track.
We have to pretend that the length is.
If you want your length to be the biggest possible, so instead of radius being 0, what if the length was 0?
Yeah.
Then if length was 0, then radius would have to be 108 divided by 2 pi.
Yeah.
So that would be 54 over pi. And again, if the length is 0, you're not really having a real cylinder, so I'll call it an open-ended endpoint. So I have a domain of R values for this problem. And like Reza said, I need to find the critical points. How do you find critical points? So B prime is equal to 216 pi R minus 6 pi squared R squared. So critical means I put B prime equal to 0, and if B prime is equal to 0, then you got 216 pi times. Let me factor an R out. So I'm going to factor an R out. That's R is times 216 pi minus 6 pi squared. That means R is equal to 0, or R is equal to 16 divided by 6 is 36, I guess. So then pi divided by pi squared is 36 over pi, it's like. So there's my critical values. R equals 0 is not in my domain, because I decided on an open-ended 0 endpoint. So I only have one critical value that's in the domain. So the way I test this now is I test the endpoints, but because they're open endpoints, I can't just plug them in. I have to do a limit, which effectively becomes a plug-in. So I do the limit. X approaches 0 from the right. I'm sorry, R. R approaches 0 from the right. B of R, right here, B of R. So B of R So if R gets close to 0, then that's a 0 and that's a 0, so this is a 0. And if I check the other endpoint, I can do the limit R gets close to 54 over pi V of R. And by the continuity theorem, I can sort of plug that in and see what happens. Let's see. I'm gonna go back up a level before I distribute it. It might be easier. So I plug in a 54 over pi. That becomes a 108. 108 minus 108 is 0, and 0 times all that is 0. So I get a 0 again, which kind of makes sense to me. If I make the radius be 0, then I'm going to get no volume. And if I make the length be 0, which gives me a radius of that, then I'm going to get 0 volume. So both of those are not the max. Neither one of those are the maximum volume. So I'm going to assume this one's going to be. So all we have to do is evaluate volume of 36 over pi.
Now, would you put that into the equation that only has the R's in it?
Yeah, we plug it into B.
The
is
variant
B
of B with only R's, as
Yeah.
opposed to the with an L.
I mean, because we've already substituted what L is, so one of these two work. I'm going to use the first one because I think it'll be easier arithmetically. So the pi's cancel here. 2 times 36 is 72. 72 from 108 is 108. 8 is 36. Yeah, 36. I got a 36 there, and then I got to put in that. That's going to be a 36 cubed over pi, whatever that is. That would be your, if I do my arithmetic right, that would be your maximum volume. Answer your question, Chloe?
Yeah.
Yeah. Okay. Right, because effectively this is just a constant. I definitely back up, put it on the board again. So this 2 pi pi squared is a constant, just like 108 pi is a constant. So if you do the derivative of that, you get 2r. So you multiply the 2 times that, do the derivative of that, you get a 3r squared, and you multiply the 3 times the constant. Okay. Did you figure one out, Joe, that 1.3 So this is 1.3, number 25. Says my maximum delta there if x is an element of 1, Sure. 1 plus delta. And
Yes. I remember this.
absolute value of square root of x minus 1 minus 0. That's 0.5. Okay. So just first, I'm going to think a little bit graphically. I'm going to say this out just because I have my thinking on that. The graph of this function, the square root of x minus 1, is the square root function shifted to the right one. There's a 1. And apparently they're forming delta intervals starting at 1, at an open interval there at 1, and then close at 1 plus delta. So that distance is delta. This distance here to here is delta. We want to be able to pick any x value in there and have the y values, the distance between this function and 0. Here's 0. And then some value. So there's f of x. We want this distance here to be 0.5. How can I do that? We all got the picture? I remember doing this.
Mm-hmm.
It's been a while, yeah. I'm like, yeah, that's been a while. I had to. So I drew a picture to help me remember how to do this. Let's see. So we want to find this number there as an x value distance, so that when I evaluate that up here at the function, the distance up from the 0x is no more than 0.5. So I guess what I'm saying is I want f of 1 plus delta. Since f of 1 plus delta, and I want the minus 0, so it's minus 0. I want minus 0 to be less than 0.5. So again, this is f of x equals the square root of x minus 1. So that means I've got the square root of 1 plus delta minus 1. So that's 0.5. I look down this.
Yeah.
I want to find that delta value algebraically. I want this function height minus the 0 height because I'm starting at 0. So that I want this distance. I object one more time. When I get out to a delta value right here, when I get that far out, I want this distance right there to be 0.5. So that's all I do.
Wouldn't it be piecewise be the absolute value?
Well, technically, it should be piecewise absolute value. You're right, but because we're only on one side of things, you understand? Normally, we would have two sides, but we only have one side this time.
Yeah.
Okay, as a review, when we looked at this initially, have the delta going to the right side or to the left side of it. Remember that? And you had to, one side might be bigger than the other, and you had to pick the smaller of the two so that you always got it trapped correctly. Well, this time there's only going to be one side that we have to worry about because the left side of it, there's nothing there. There's no function. That makes sense, Rizzo? It's a good question, but in this case, we don't need to worry about it.
Okay. So what you do is you're looking for when it's less than 0.5. Is that just the answer, the square root of delta?
Yeah, and then so delta is just less than.
Okay.
They give it, they give one now.
Well, they might just give you a number like that.
Okay, just wait. There's the delta epsilon proofs.
I don't think one of this is going to be
Just you wait.
I mean, that's your biggest delta, 0.25. That was the question was find the max delta. There it is, 0.25. I go past 0.25 on my delta, then I'll be out here, and when I plug in the function, I'll be too high, I'll be too far away from the.
Nice.
Actually, the question is max delta is 0.25.
Okay. What is next on this? Hey, do you think we're gonna have to do, guys?
Okay.
But-
What other questions y'all want to talk about? No? Well, I guess the first question. Anybody follow that?
Yeah.
Other questions?
We're gonna have to know how to use the definition of a derivative. Like the really lengthy one, like half of one minus h. Yeah, Mr. Gaddis,
Yes.
are we gonna have to know how to figure out a derivative by the lengthy method by using the definition?
Multiple choice. I'm not grading your work. So how you achieve the answer is.
I'm just
I'm
wondering
not sure if I follow your question.
Okay, it's just up to me.
It's up to you because
It's
it's
up
a
to-
final.
I think it was just to get a foundation before we went into short.
Yeah.
Okay.
All of this was a foundational type of each one.
I mean,
Okay.
potentially, how could you ask a multiple choice question that could involve and you call it lengthy method, meaning based on the definition?
What's the
How could a
definition?
multiple choice question be posed to you that would involve that? I mean, if they say to you on a multiple choice question, use the definition to find the derivative, and your answer is just a derivative answer, I'm not going to check that you did the definition. I'm just going to check whether you got the right derivative. That would be a meaningless question other than just finding the derivative. But how could they ask a question that would check your understanding of the definition of derivative?
What's the definition of a derivative? Is that a good question?
Oh, I guess they could ask the definition and provide you the answer in different ways. So yeah, and as we discussed earlier, we can look at ways that they can miswrite the definition.
Oh, snap.
What is the definition of a derivative?
What is it? The limit as h approaches 0 of f of x plus h minus f of x over h.
Correct. That's the definition. How could they rewrite it in a multiple choice fashion to make it seemingly look sort of right, but then actually be wrong? Maybe not put a limit. Or maybe put a limit x goes to 0 instead of h goes to 0. Ooh, so something little sneaky like that. You know, if h is your limit variable, and you want it to shrink, it's in the denominator, then you want h to go to 0. You could change the h to a whole different letter and still be correct. They could have limit h, instead of h, maybe limit w goes to 0, and f of x plus w minus f of x over w would still be correct. Also, they might, another thing I'm thinking is, giving you a function, asked based on the definition, what would the definition say about the derivative? That means just use that function in that definition, but not simplify it like we did with the limit. Just type in state. I wouldn't expect a lot of that, but it is possible all I'm saying.
All right.
Question?
Okay, can I ask like a clarification question?
Did you get that out clearly yet?
Yeah.
That's cool. Yeah, what's your question?
Okay, so when it comes to evaluating a limit, if you know that it's continuous, you can just plug in whatever it's approaching.
Yes, that was the continuity term.
Okay, just making sure. But now we can cheat because if we get an indeterminate form, we can use La Hospital. Is that
Right.
correct? Okay.
Because all the tools you learn now. So some of that earlier work is a lot simpler now with local than it was before.
Some of that the only
See, learning is cheating if you just learn it in your head.
Actually, I haven't looked at the test. Other than look how many questions. I wasn't even the one who wrote the test.
Hey, I'm gonna do
No.
this. Okay. I need to explain this to me really quickly.
I didn't even look at it. I don't know what's on it. To be honest. I mean, it's like any other multiple choice question. They can sometimes be a little sneaky. Like think about the true false questions in the problem ones that we studied. All those problem one questions were true false. I mean, seemingly true false should be easy, but they can get sneaky on you.
Yeah,
And the same idea can happen with multiple choice. I mean, I would think most of it is just purely computational, applying the the rules you've learned about derivatives and/or integrals, and just most of it is going to be just straight up computation. Some of it can be a little more understanding conceptual than it is computational.
So these are the two that have to leave for their final exam at 9 o'clock.
Yeah, Carson does.
That raises the points for 10 minutes.
Say what?
It's okay. It's okay.
What did it say?
Good luck, guys.
Yeah.
Have fun. What class is it?
It's like exams.
Oh, heaven help. Chemistry?
We got a compliment for your hat, Rizzo.
Compliment on your hat.
Thanks. I appreciate it.
Hey. Yeah, how cold is it? Cold there, I guess?
Yeah, and it's just really comfy too, honestly.
I just wonder, I mean, cold here. All right, what other questions for the remaining few trials? I don't know it's enough, but I think that would be something to do as well. Yeah, I would definitely practice a little bit very hard, for sure. What other questions y'all want? It's very, very slim.
Not looking at it.
It is. All I can say is study everything. Fortunately, you don't have to write down definitions. You don't have to prove anything. So that should simplify some things a good bit, I would think.
Okay, I found the question.
Hey, yes, boy.
Can we go to 3.5 and do number 57?
557.
I know, I remember doing it.
Okay. Oh, we don't know. So number 57, page 300 says, Riley is holding an ice cream cone on a hot summer day. As usual, the cone has a small hole at the bottom. And ice cream is melting and dripping through a hole at a rate of a half a cubic inch per minute. The cone has a radius of 2 inches. How fast is the height of the ice cream changing when the height of the ice cream in the cone is 3 inches? Okay. So we have an ice cream cone shaped like this. And this height is 5 inches. And this radius is 2 inches. And then inside there we have some, I'm going to go with my favorite, mint chocolate chip. Anybody else like mint chocolate chip? If you don't, then you don't know, you don't know what you're missing. So we have some ice cream in here. And it is dripping out. And we are given that the rate of drippage, V of ice cream, equals we're losing it at a rate of negative 1/2 inch cubed per minute. And then we're supposed to find how fast is the height of the ice cream changing. So we'll call this dimension here the height of the ice cream. And we're supposed to find the H to T. And the ice cream is 3 inches, and the height is 3 inches. So I guess we need to know what that number is there. That number is all that R. Okay, so what we need to do is set up an equation involving volume and height for the ice cream. Not for the whole cone, just for the ice cream portion of it. Volume of the cone is, let's see. Volume of the cone. If I remember what the volume of the cone is. 1/3 pi r squared height. 1/3 pi r squared height. That's the volume of the ice cream itself, of the cone shape. The problem is that this equation has B, R, and H in it, but we need to only have B and H in it. So somehow we have to replace the R by an H, some relationship. We use similar triangles again. So it appears to me that, let's see, I want to find R. So R over H is equal to 2 over 5. So therefore R is 2/5 of H. And I can now substitute that in here. So I have B is equal to 1/3 pi times 2/5 of H squared times H. And then I could simplify that a little bit before I do the derivative. Let's see, so that's going to be a 4 and a 25, so 4 over 75 times pi H cubed. And dt, particular derivative with respect to t, is, well, 3 cancels 75 and 25. So 4 over 25 pi H squared dH dt by chain rule. So if I solve for dH dt, which is what we're trying to find, so dH dt is equal to dV dt divided by 4 over 25 pi H squared. So dH dt evaluated at H equals 3 is dV dt, which was -1/2 inches cubed per minute over 4/25 pi times 3 inches squared. So I'm going to come out with whatever that is. That's 9 times 4 is 36. 25, so -25 over 72 pi inches per Any questions on that? Again, the thinking process is you're given one rate of change, and then you want to find a related rate of change. And so I had to create an equation that involved both B and H, since those are the two related rates I want. So I managed to do that by knowing a volume equation for cone, and then similar triangles, proportionality there, to get down to the two variables I want. The rest is differentiating and then plugging in each other. Well, does that answer your question?
Yeah, thank you.
So we gotta write down what we're given, and we gotta put it in terms of one variable.
What's next?
And then plug in the answer.
I'll see one of the tests. Really analyze the links, find the steps. That's this one be just one step. That's it. About the graphing and stuff? Yeah. I'm not sure. Again, hard to that question, but I don't know how it's not like it can't be open-ended. So the question is, what about the graphing part? So at Davidson, on here, question is about graphing and how is that going to be handled? And I honestly, again, have not looked at the questions on the test. So I don't know. I would bet there's some kind of graphing question, but it's not open-ended, so it's not going to be, we'll make the graph of this function based on all this work we did. So it's multiple choice. I mean, I guess how that can be handled probably be more like find the critical values or find the intervals that it's increasing or decreasing, or something like that, which is related to graphing. And so they might just give you, A, B, C, D different intervals and say which ones of these are the increase and the decrease or something like that. So that would be more like what I would expect on the test, I would think, rather than straight up graphing. Because if they just give you a graph and say pick the right graph where you got your calculator, that's not much of a question there. So, but you have a calculator for everything else, that saves a lot of time and effort as well. Well, we went over yesterday how to do the interval, right? That's the idea. If you mess around, you can figure out how to do the derivative on there too. Again, the derivative has to be the derivative evaluated out of a value. That's not so hard. The interval is definitely an interval between two points. So that may help some. Point 2, number 32. 4.2, number 32. I'm on page 340. Give an approximation method to approximate the signed area between the graph of f and the x-axis on the wave. Determine whether it's likely to be an over or an under approximation. Number is 32. 32. So 4.2, number 32, says f of x is equal to 9 minus x squared, and it's on the interval from 0 to 5, and we want to do n equals 5. And it says midpoint and lower sum. So we want to do a midpoint with 5 rectangles, and B, I don't know if we made up a special symbol, but we'll just call it lower. We use capital L for left. That's not necessarily lower. First thing I would do is make sure I'm aware of what the picture looks like. So on 0 to 5, that's 9. So 9 minus x squared. Something like that. If that's a 5 there. I guess it's probably going to cross the axis at 3 right there. So if I'm going to do a midpoint with 5 rectangles, then I need to form 5 rectangles. So it's going to be a 1, be a 2, it's going to be a 3, and it's going to be a 4, and it's going to be a 5. So then so this is going to be the midpoint. So within each of these, I find the midpoint halfway between. So that's 0.5, and that's 1.5, 2.5. And then I have to go up and put a cap on my rectangle at that location. And then I have to add up those areas. This is going to be f of 0.5 plus f of 1.5 plus f of 2.5 plus f of 3.5 plus f of 4.5 times delta x. And f of 0.5, you're just plugging in now. So 9 minus a fourth is 8 and 3/4. So whatever that is, 35/4. 1.5 is 3/2, so that's 9/4 of 36. It's 27/4. 5/2 25/4 from 36/4 is 11/4. 7/2 is 49/4 from 36/4 is -13/4. What's that? 9/2, I guess. So that's 81/4 from 36/4 is -45. 45/4. Delta x is a 1. Whatever that comes up to be. I did that right then. 36/4 minus 81/4. That's 45. I got that right. So add those up. You get 273, 60. I get 15/4. Get that? Okay, 15/4 is what I got. For the midpoint sum, how at that point in time, we can have the fundamental theorem, but we can easily check what the exact answer is to see if this is an over and under. Just graphically, what do you think? Is that an over or an under? I don't think it's a whole lot off. It might be slightly under, but you can do an exact value to find out. So integral from 0 to 5 of 9 minus x squared dx equals 9x minus 1/3 x cubed from 0 to 5. That's 45 minus 125 thirds minus 0. That's 45. 135 minus 125 is
10 thirds.
10 thirds.
Yeah.
10 thirds is 3 1/3, and this is 3 3/4, so this slide over approximation. Okay. Thank you. How do we do the lower sum?
What is the lower sum? What's lower? We just do
Yes. We're always going to pick the lower end of each rectangle, so the lower sum is going to be on this one, the right hand each time.
it's right, and then it's left. Right. Yeah.
And so a lower sum is going to be that's definitely going to be under, because we forced it to be under, we're picking the lower end. But it's just the same idea, except you're doing always the right end. So the lower sum on this one is the right sum of 5. Not always the right sum, but this one is. And so that's just f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 times delta x. So what is that? 8 plus 5 plus 0 plus -7 plus -14 times 1. No, wait. 25.9 is 16. So what is that as? All right. That's definitely an under approximation by a significant amount. Okay. Yeah, being able to do an approximation. I mean, we've got to be able to do the definition. That was kind of what we led up to. The whole thing with the fundamental theorem of calculus, we've been leading up to that the whole semester. That's certainly key. But being able to do an approximation correctly is also important. It's about time. Yes, it is. It's tea time. All right, well, see you tomorrow. We'll plan tomorrow to have a regular meeting time, 8 o'clock to 9:05 for first 15 questions. Questions are roughly chronological, but I don't know the exact split. In other words, the split isn't necessarily right at the end of a block. It could just be in the middle of a block. It's just, here's 30 questions, here's first 15, there's the last 15. They are roughly chronological. Okay. So,
I'm not gonna sleep. Do that. Sammy, will you pull the door shut and shut the light?